Welcome again to today's presentation on programming and team management. Our presenter today is Lee Magpili of LEGO Education. Lee has been mentoring in First LEGO League in the Bronx since 2006 and had his own team from 2007 to 2011. That team actually still continues today. He's been a regular at the First LEGO League World Festival the last few years, as well as some other First LEGO League championships in Europe. He is an avid LEGO fan and now works on the design team at LEGO Education, including on the LEGO Mindstorms Education EV3 core set, which I think you're all probably familiar with. Lee has also been a member of the First LEGO League Challenge Advisory Team and is a critical part of designing the annual challenge. I'm going to go ahead now and turn our presentation over to Lee.
Hey guys, thanks for having me again, and looking forward to hearing all the feedback you guys have on Trash Trek this year, because we were really excited on building the challenge, and we put all this cool new stuff in there, like that composter and that sorting machine. So, and a little nod to the classic space up there too. So, let's see what you guys have.
Lee, I was wondering if you could maybe share the folks on the line today how you approached your decision-making process with your team.
We tried to make a good voting process of some sort. We had always had the team to pick out some decisions like what to put on the motors or where to put on the motors, and I had the team vote on it. That's usually one of the ways to go. And sometimes if the teams were separated into different roles, I'd have those guys have the kind of like that final vote into, okay, what do we go with? You know, what do you think is going to be best for the team? So I let them really make that decision, though I'd guide them and say, you know, I think this is going to be good as well. And once they make the decision, they can go forward. So it's a fun little engineering process, but sometimes we don't have a lot of time, so we'll make the choices relatively quickly, you know, within half an hour or an hour, just to make sure it was talked about before we go on. So, yeah, decisions, engineering. You know, we can always make decision trees and weighted decisions, but that might be a little tough for the team at the very beginning.
How would you approach between deciding the base robot and attachments to solve individual tasks?
You know, it has to work first, and you know, the base robot needs to make sure you can get around and fit around all the obstacles, and your attachment needs to be able to kind of get onto the robot easily. So what can the team do fast, and what will work? So I actually kind of picked the one that will do fast first, because they have to change the attachments at some point. So, and then when they can get that and get the muscle memory for it, they'll be able to get it working onto the robot.
We have a coach on the line today that has a 4th grade team, and it may be difficult to teach them programming concepts. They're wondering, what are some good resources to start for the coach? And just as a reference, they themselves are quite familiar with software programming.
So I'd actually, just for the teams, I'd start with the robot educator in the software, and just to get them kind of interested in understanding the blocks. You have loads of tutorials in here that can teach them about the individual programming blocks, just as a starter. And then to get them to think how easy it is to start, you know, just get a few blocks in, and moving one block in for me, you know, that's your first program. And it's that easy. And kind of trying to get them to understand the relationship between, you know, what a turn is versus what power is and how long it is to go. Because, you know, as a beginner team, they really won't need to use that many more of the blocks. But, you know, it'd be good to get them to kind of get a healthy understanding of what each block does. And it's not about, you know, they don't have to really do so much initialization with this one. And when it when compared to other robotic languages, programming languages. So here they kind of plug and play and kind of make sure all the motors are in the right place and get them started that way. So just to start thinking sequentially. And really super important for you or the team to, think about comments, especially at the big early level. So making sure that those kind of comments are in there so that you can go into their program and ask them questions directly on top of it. And vice versa, they can explain what's happening.
So we have a couple questions from coaches who are wondering how you organize your teams. Do you typically have one or two primary programs, or do you get everybody in on it? And then how do you organize those programs on the EV3? Also, how do you decide who builds and who programs? And do you separate by missions or capabilities?
This is a big one. I'll start with how I separate the team. Usually on my teams, I've had one very strong builder who can take one or two other of the teammates to kind of be the lead designers on the team. Something that I've done in the past is kind of very early on, I want them to understand why to design a robot in certain ways. So I have them measure the field, what's the biggest dimensions the robot can be. I have the team pick what kind of wheels they want to use, where they want to put the sensors, and we'll do like as a team lay out the robot and kind of figure out how it can be built. And then I'll have the strong builders kind of put everything together. And then after that, I'll have the rest of the team, once the robot is built, is have the rest of the team make a copy of the robot so that they know how to put it together as well and understand some of the decisions that went into creating the robot the way the builders did. And as for programs, again, depending on the exercise, I like to let the whole team work on certain missions during the day. But as a whole thing, I'd like to have a responsible programmer who's kind of responsible for kind of collating all of the programs, no matter which way they put them together. So even if everyone on the team got to write a single program, I'd have the team programmer kind of collate everything and put it into one big program or put it into the robot so that the team can find a way to do it. One thing I do is I teach my team how to write a large program, which has all of the team programs in it, and there's lots of different ways of doing that, but the way I do it is with what's called a state machine, which is a way of picking through the blocks, each program, picking through each program and then running them individually. And what this does is allow the team to have only one program to change through, and they can pick through the programs using the in programming language, or they can use the touch sensor to pick through, or the buttons, and they'll be able to run the program in sequence much better. It does create a much larger program for their robots, but I think in the long run it'll save them time in having to look through missions during the actual robot game. So this is quite advanced for most coaches, but it is a way, something that they could learn. One thing to do is when you're looking through the programs, really name them very well. Have some sort of display so that you can see if you're running the right program. So maybe you can have image files and have the right kind of eyes to do it. So maybe that's one of your programs that's running the eyes, or you can just have a big number 1. So you can see what exactly you're running, even if you mess up in picking up the program name. So there's a lot of ways of doing it. I think it's really best to kind of experiment in what you can do, especially if you're a beginner team and trying to write the programs themselves and try to keep it quite neat. What's cool in the EV3 language is that each one of your programs is in the same file, so that when you're looking for it, you can find all the files here, and make sure to name them really well so that you can find them really easily. I challenge you coaches to kind of count the number of button presses it takes to change a program from the time you run it, get it back, and then change to the next program and then run that one. So once you do that, you'll figure out why it is better to have a single program that can run all the robots. So I can pretty much go from maybe 11 or 12 button presses to just having one press to change my program, and you can do that, and you can do that within the programming language. So I hope it's clear. It's this is a good one, but thanks for the question.
One of our coaches is saying, so instead of picking from the folders on the EV3, you use program control interaction with the touch sensor. Is that correct? And can you possibly post an example?
So what I'm doing here is I can make a variable here called state. Yeah. And then, say each one of these move blocks is a full program that the robot does. So each one of them is a mission. So I can change the state in different ways. So here I can change the state right after the run block. So, and actually, so this is actually automatic, and this will run in sequence, right? But what I can do next is I can have a touch sensor change the state variable as well. So I can do a wait for touch. So once the touch sensor is pressed, I can have the state number, add 1, back to state. All right. And what I can also do is, I don't want that number to be greater than 3, so I can say logic here, greater than 3. So if this state is greater than 3, for example, I want to make the state back to 0. So this is one way of changing the states going through so that I can always run the one that I want to run on time. And here, what I would do is just put a, oops. Here would be my brick button. So I can have a wait for press before another one runs. So this is a really very basic example of a state machine. And a real great way of making the robot run the way you want to and saving some time. So I hope that's a good one.
So we do have one coach who's asking, is there another good source for tutorials or learning program besides Robot Educator if we don't happen to have that software?
There's actually a lot of question and answer on the Lego Mindstorms EV3 Facebook page, which is a great resource for FLL teams. There's a kid named Builder Dude. He's from New York, and he does tutorials on line following and building robots. There is Droids Robotics and EV3lessons.com, all actually from kids and teams who are sharing their own programming resources. So there is a lot out there, and of course, there's also the LEGO Education community website where you can find us sometimes directly on asking on getting some resources and help on FLL, and then really you can almost Google search it anytime. Because there is so much help on programming, FLL programming from the last X amount of years that we've had people uploading their code to just even show research judges, the robotics design judges. So, get some help from your fellow teammates around the world.
Yes, it's really amazing to see the resources that the teams themselves have created. So I definitely recommend taking a look in your team forums as well. If you go to firstlegoleague.org, you can find a link to the team forums and talk to other teams directly to see what they recommend and what they're using. What you were saying about the large program, what would a coach look up to learn more about this?
I would do state machine, program switching. What else is in there? Increment and decrementing. That's kind of like incrementing and decrementing is learning how to add 1 or 2 to a variable, add 1 or minus 1 to a variable. My block building, which is actually being able to create your own giant blocks from missions. So I'll do a quick example of one here. So I'll do like 2 blocks or 3 just to make it, that's a mission, right? Going forward, activate something, and then come back to base. And then I just select them all, tools, my block builder, and then mission 1, pick an icon, and then finish. So what that's going to do is allow me to run a mission just from this block, and then I can put that into my big program here. So instead of so here's my mission 1, and then wait for my touch sensor, my brick button, run mission 1. When the state changes, it goes to the next one, and then I can run this mission. It'll change. It'll wait for me to press and then run to the 3rd mission. So that's something you can look up. I don't know what other teams have been calling him, but sometimes it's just as easy as FLL one big program. So I've heard teams call it that too, and I've seen that as a judge. So it'd be good to teach them the right terms, but they also need to just get it done.
So we had a coach who had a question about the state programming that you were demonstrating earlier. If they wanted to try to understand that further, how would they go about doing that?
So I think the best thing is to actually play with it and make one. And when this is recorded, you can take a look again at how I wrote this really basic program. And that's going to be, I think, the most major and best way to really understand the program and find the way that works for you. There's a lot about displaying the state number. Can you actually see what this means? Because for all real intensive purposes, this is quite easy to kind of get where things go. In a language programming, you wouldn't be able to see it this way because you'd have to write these all in this sequence without really seeing what happens straight. So I can always follow this state through mission 1, state 2. So once this state is changed, I know that it goes around and comes back and will do this one, this second state. You know. I'll add another tip here that you should probably have a state that does nothing, just to make sure when the robot isn't being pressed or nothing is being touched, that the robot doesn't move. So you want to make that the default case. So there's a lot of little tips and tricks like that that you'll need to find out really as you play with it. I don't know what other resources like really explain it this way, mainly because I taught this to myself and I try to teach it to other teams, and it's quite complex for most beginner level teams. But again, you'll have to play with it and do it yourself, no matter what books and websites teach you. So feel free to experiment. And there is more than one way of doing this, but this one has really worked well for me, and I've seen a lot of teams use this in many different fashions as well.
As a follow-up from the same coach, she's asking, is the state programming a sequence of if-then statements? Is that the gist of it? Or is it a sequence that is followed 1, 2, 3?
It's a sequence of if-thens. So if the state is 1, then it will run the top program. If the state is 2, it will run this program. So what I can do is, right now it can run in sequence the way I'm having it go, but maybe, when state is 0, for example, it's doing nothing. I can change the state at any time right here. So as long as I can change the state manually, if the state is 3 at any given point, then it will run this. And you can see this state doesn't change. So actually, if I run state 3 and it goes back through the loop, it'll run state 3 again. So it's always going to be state 3. So it's not it can be non-sequential. I can even change this back to 1 at any time. I can change this state back. I can have this one run back to 0. So I can actually really customize what happens. And the reason I make it go into the sequence is that this is the program sequence I need to do. But maybe my team needs to repeat a mission. So, okay, if I messed up mission 1, I'd want to go back to do mission 1 again. And I can use that using the touch sensor. So it is a big series of if-then statements.
So I want to back up a little bit for the folks who are brand new. We've got a great question from a coach who's asking, do you have to have a finished robot before you start the missions, or does the robot need to change as you learn to tackle the missions?
Your robot will probably change as you tackle the missions. Though, I guess that's something that would help you is to have as much of a finished driving base as possible. So at least some things don't change, such as like your turning radius and what kind of wheels you use. But maybe you'll find out that the wheels you need to change to get to the point B faster, or your attachment has changed, so you need to get from maybe you're facing the left side of the mission or the right side of the mission. So in that sense, the robot changes as your attachment changes and you're tackling the missions. We try to keep as much of the base as possible. There are some great resources out there. I've seen some LDD files of team robots actually in full. So there's things you can look at. But as coaches, I'd like you to be able to understand the design of your robot, and even though you can pick someone else's robot out there, it might be good to really understand it before you give it to your team, or let the team kind of design their own solution so that they do learn how to make a robot and why they put things here and there.
So we have one coach who's asking, if you have a team that has a a range of ages, for example, 4th to 6th graders, how do you incorporate younger kids into programming instead of delegating all to the older ones?
I would definitely pair them up into one older kid and one younger kid, if that's possible. Um, or I'd make each kid responsible for a certain program. So no matter what, um, they have some kind of equal footing, you know. And usually at that point when it's mixed like that, I found that the kids are actually at a very similar level when it comes to programming. And by the time to get to FLL, I like to get the younger kids as empowered as possible. So they might have a skill that the 6th graders don't have. Maybe great presenters. Maybe the 4th grader is a better builder than one of the 6th graders. So to really empower them and give them some extra stuff that maybe the 6th graders don't have, and vice versa. So it's going to be a series of skills that your kids are going to have. There's a level of praise that you'll need to give, but without giving them any special treatment. So if you treat them like equals, they'll really feel like they're part of the team, and don't let their age um, feel like it's a disadvantage for them. So you'd be surprised at the power of the 4th grader over a 6th grader sometimes at these competitions. So I've seen it more than once that the younger teams can beat up the older teams just because they have a better imagination.
When you're personally teaching a programming concept to your teams in the past,
Mhm.
do you usually make the kids begin from scratch or have the kids start from scratch, or do you give them an example first?
I try to give them an example first, something that they can relate to. Um, this might be an example I might give them, this program, so that they understand how this program works. And what I'd ask them to do is modify it to see if they can really get it to do what they want it to do. So a good example here, without doing it for the kids, is instead of making motor sounds, I would have it do play different files. I'd make it cat purr, and then I'd make it, do another sound here, so that they understand that they can get this all to happen one after the other. So I said, okay, and so once you've done this, what if you could put the motors to move this way? What if you can get you know, change the cat purr to the motor movement and then the snake rattle without really having to change moving the blocks around. So you can even change the way it starts. Um, so I give them this kind of a programming concept idea. And then I'll kind of help them walk through creating it themselves. Because it's just kind of a matter of pressing the right buttons, adding a case, changing the numbers here, changing this number. When it comes to more complex examples, it's a lot of trial and error, especially with line following concepts. There's this type with the color sensor and and the motors. So I give them this and say, okay, make it move better. What's a better line follower than this? Is 50 power the best thing that they can do? Or they'd have to really try these really cool examples where it's the dynamic color sensors, and it'd be something like this with the steering. So this is a different type of And this is two different line followers that might work for teams. So I'd want them to experiment within the two. So I would give them a small example before just giving it to them. You know, the next thing is learning how to stop. So they need to learn how to do that as well.
Now, one coach is saying an older team member suggested having the younger fourth graders practice with the NXT before getting into the EV3. She feels that will take too much time away from their progress and would like to introduce them to the EV3 right away. She's just curious about your thoughts on that.
I think I try to keep them all on the same platform as much as possible, because it depends on your material. So if they have more than one EV3, great, then use it. If the NXT can actually use the EV3 programming language, so you can actually move. This would still move an EV3 block, an NXT as well. And here, I think you can actually see some of the old NXT blocks, and you can use the color sensor here to move the NXT. So don't feel too bad about having them equal. So, but if you don't have the right materials, it'd be good to practice. But again, you know, don't let their age be their detriment, and let them work together, and say this is the best way to practice for them. You know, it's like giving a sixth grader and a fourth grader two different basketballs. Shoot at the basket. You know, maybe the heights are different, but they still need to shoot the same ball.
So just kind of backing out a little bit, we have a coach who says that they've been losing some students who registered in robotics who don't want to program. The students consider themselves builders. Do you have any suggestions to reduce the attrition rate?
We'll have them build. You know, this is going to be a strong point for them, and building great robots is going to be I think you should be able to challenge them in building, you know, stronger robots. And if you really want to challenge them about programming, I think it would be to have them think about the programmers while they're building. So it's about the placement of the sensors, the placement of the attachments will really affect the programming that they do. And if you let them build on their strengths. You know, not all kids can be goalies in soccer, and not all kids can shoot, and you know they have different positions for those teams. So I think it's important to allow them to play towards their strengths, and you know, why is it important for them to learn how to program? Because they can make their creations better. You know, so it's spinning their wheels a bit, and learning how they fit into the role of this team.
As a follow-up to that, one of the coaches is asking for clarification. So it's okay to have kids on the team who don't program? I thought kids had to be familiar with all the parts.
They should be familiar with all the parts, but if the kid isn't comfortable programming, he probably shouldn't do it. But he should be familiar with it. He doesn't have to do it as his main role, but he should know enough about the programming to say, okay, if I use this wheel, how many rotations does it take to get from point A to point B? You know, he needs to relay that information to his programmers. And it's a good way to get them interested in the programming, to understand that what they do as a build relates to what happens in the programming environment. Whether they like it or not, that's how it's going to be. You know, if they build something funny like, you know, if the color sensor is too high from the ground, it'll really affect the performance of the program. So they'll have to work really closely together with the programmer, and to be sure that the team robot is actually doing what it needs to do. So I think it's okay for a builder to not program. So if that's his strength, but he should be familiar with it, but he doesn't have to do it as as a main role. Again, it's the same with any team sport, you know. Uh, not all not all baseball players can pitch, for example, but they all can throw a ball.
That's a great analogy, and you just don't want anybody on your team doing things completely in a vacuum.
Yeah, in a vacuum. So they need to know that they're part of the team. So, you know, just because they're not doing one part, they can be another. You know, defense, offense, and football. You know, they don't all play the same positions. But
So I have a question from a coach who says our team meets 2 nights a week for about 2 hours each night. Do you have a suggestion on how much time they should be giving to programming?
uh, it depends on what kind of drills you want to run, and that's going to be another sports analogy. So, you know, maybe you could spend a whole one session on programming just to kind of make sure everyone's on the same page. Um, you know, if you want to really break it down into the the way FIRST really works, you're going to spend at least half of your time programming and the other half building the robots, and the other half and anything half related to robots, and the rest is you know, spending time on a research project and core values presentations and your teamwork. So you'll have to kind of decide that week and how to plan your time actually throughout the season. So especially when you have only limited time, 4 hours during you know, 6 to 8 weeks, it's like, okay, we need to get all our programming done by week 7, and competition is in week 8, so we have time to practice. You know, so just kind of levy your time that way instead of thinking of it as a week to week. Think of the season and plan your way out. Because it's good to get the programming done relatively early, but you're gonna be making changes all the way up until competition.
So we have a couple questions coming in about design. Do you have any resources you would recommend for basic mechanical structures that are useful in building the robot, such as gear trains, linkages, and drivetrains?
I would find this guy. Find his books, Yoshihito Isugawa. He's got these fantastic series of books that have lots of things on mechanics and drivetrains and the like. And again, actually, I think there was a Portuguese blog called where I found all these driving bases from other teams, which is really cool to take a look at. And again, just I think it's good to experiment a bit. We'll go back to Builder Dude. I think his name is Kyle, and UV3 lessons. So those guys also have lessons on builds and drivetrains and mechanics as well. And it is tough to find all these resources. There's actually so many out there that you could probably fill a book on just where the resources are. But I think these are great starts for you guys, and get yourself Google Translate on this one. But these are really great resources. I even use them as well in my work. So.
One of our coaches is asking, we went through an EV3 tutorial that taught us the use of sensors by putting in a weight block and setting it to what sensor they want to use. But we noticed the yellow tabbed units that can be dragged in for sensor programming. What's the difference between using a weight block versus the yellow sensor specific blocks?
Okay, so I have one here actually. So here is called, the yellow blocks are called dynamic sensors. And what you can do there is read the sensor value live directly at any time during the program is running. So in this loop, this sensor is being read at all times, as each time that the loop is running. Whereas in a wait for block, it's called passive. So I can write even a line follower block this way. This one. So this one will always wait for the things to change. It's kind of, we call it's a bit dumb in that sense, but this one will read all the time. The top one will read all the time, and then the bottom one will have to wait for each sequence to happen. So this is more sequential in this sense. Where here I can get the value and do something with it, which is quite cool. Really great for these smoother line followers, exact like this, or even this one. So especially if you need to sort colors out, it's really important to kind of know what color it is. So maybe with this one, like this one, great for the gyro sensor as well. So where's the color sensor? So in this one, where I can measure the color, I can have the robot do something based on the color. So I've seen some teams do this as well. And I can have the robot do something here. So when this happens, the robot will read the color and then do this action in 1 to 6. And it can read actually up to 7 colors. So quite cool, especially for the gyro sensor. When you're transferring data out of the gyro sensor, you really get a live update on what's happening to the robot. So there's another way of doing that. So one is a wait, and one is a kind of a dynamic sensor as opposed to reading. And actually, and I'll do it to kind of close that one off. I'm going to compare reflected light sensing. So actually this, if you notice this block in a loop, this yellow block in a loop, actually kind of looks like this one. Okay, this structure works the same way as this one. So this one and this one are actually, you can kind of interchange them as exactly the same. So we really made it a little bit simpler for you to have this in an orange block, because then you'd be writing it all the time. But I really like being able to do something with this information other than just popping it out, popping out of this loop. Is I can turn this into variables. I can take the information here and store it. And maybe I need that for something else. So I can't do that with this one. Actually, I can, but that's one way of explaining the difference between the two.
One of the coaches is asking, what do you feel is the most underutilized programming method or function?
Wow. I would actually say probably using touch sensors in different ways, using them to change programs, taking advantage of the brick buttons, because you kind of have all these cool buttons that you can measure. For example, you have all these for changing programs or using them. I think something that's not used that much, or though I haven't seen it, is really steering in different ways and driving in curves as you need to. So I haven't seen this too much. And what else? I don't see the timer used too often. but again, if you need it. I've seen some teams last year do a lot of work with data logging, which is really cool. So here you can actually measure anything that's happening to your robot for 2.5 minutes. So really cool. So I can actually run this on for. So this is probably hasn't been used too much in the last years because it is a new feature, and it's great to be able to see what happens to the robot live throughout a 2.5 minute set of missions. And maybe you can change your data this way. So that might be a cool little thing to do while your robot's moving around. And actually, the last thing that's underutilized is comments. And I'd like all of the teams to use comments more and more and more. So we have this comment block here. And we actually have in the newer versions of the software, we have a comment block that you could put right into the programming string. So please, 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 please use comments.
That's almost the perfect segue to our next question, which is there a way to print out the code with a note and explanations, especially your really large ones with embedded my blocks? How can they take a copy of their program to the tournament to explain to the judges?
Okay, so there's a couple of ways of doing this. One is actually printing the program here, and you can print the program in a forced landscape. And when you print it, you can print it as a file. So I don't know if it's in here, but when you be able to print, you can do that way. Or what I like to do is try to get this to a one-to-one. And when you write your programs, try to make them as neat as you can. And I will actually screenshot this with a print screen, and then copy and paste it if the program gets too big into an editor like Photoshop or something like that. And then add my comments. So all these comments will stay in place. And that's a good way. I've seen a lot of teams do that. You can zoom out this way, and you can actually, again, if you print screen your programming desktop, you can kind of see the program here, but you can't see everything. So it's really great to have, when you get a program like this, and you can have your my blocks, So when I open this one, so now that I know that this my block is this one, so that you can shrink your program so that it can be read on one page, which is going to be great for you and great for anyone else who needs to read your robot or program rather. It's really good.
So one of our new coaches is asking, you had earlier mentioned the idea of drills. Can you give some good examples? She's a new coach with a lot of kids, and she's really eager to build practice plans.
Awesome. Drills are great. So a drill would be, because this is a bit of a physical game for the kids, so just teaching them how to get from point A to point B. Like for this year, it might be a good idea to learn how to aim towards the sorting mission, right? So I'd even give them a program. I don't even know what it would be, like 3 rotations there, and then you need to turn a little bit, right? And then come back. Okay, so I'd even give them a program if they haven't written one already. And what I would do is have the teams go back and forth and kind of learn how to aim the robot physically. And that's actually a great drill. These are like sports drills, doing a lot of repetition. Another one is changing position of the robot. So maybe they run mission program 1, they change the program, and then they re-aim the robot and run a program again. So you don't have to have complete missions to do this. You can just go forward and backwards, just just to teach the kids what it's like to be on the field for 2 minutes and a half. It's building muscle memory, building excitement. You can make them, you can have, teams of 2 compete with each other, teams of 1 compete with each other. And you can even do these drills with line following, learning how to stop, learning how to go forward, collecting this and that. You can even do building drills where each one on the team has, 5 minutes to build a collector for a composter, and something like that. Or they have to move the octopus. Each one on the team has to move the octopus. So those are little drills that they can do. And it's actually reaching out to your other sports teams. Those coaches really understand what drills are, and finding repetitive little things that they can do. The baseball teams play catch. So what is catch for FLL? Your drama teams will know how to do team building exercises and expression. Debate teams might learn how to do speeches, speech talks, and things like that. So reach out to those guys, and they'll have some real great expertise for you.
So we have a question about, earlier you had mentioned wheels. Can you give a little summary in a nutshell of what the different types of wheels can offer?
I have pictures of them. I can do that. This is a good one. Of course. Okay. So different types of wheels, and actually I'll do the model expansion. So your different wheels and types of treads are going to give you different performances. So obviously bigger wheels will give you more distance for rotations, but you really need a little bit more power to run them. Tank treads are quite interesting. They're quite slippery, but they can give you an advantage in terrain, which isn't that big of a deal in FLL because it's almost all the same. We have these little rubber inserts in FLL in the expansion pack, and they give you a little bit more grip. There are so many types of wheels in Lego, so you're going to really want to find the ones that give you the most grip and kind of a good surface area. So sometimes these are good for turning, like the really flat ones, but they have a interesting way of touching the ground. So sometimes turns can be inaccurate on these. So you might want to find like motorcycle wheels and things like that that have a smaller point of contact. And you can see like a wheel like this, but bigger. I don't know if you can see my mouse pointer. Can you, Jen? But these are really great. These ones are really small, but I hope you can find other ones. I'm looking for other wheels. I don't have too many other wheels in this one. But if you find other Lego wheels, you're gonna be looking at the difference between speeds. There are large wheels. There are the ones that have great contact to the ground, and the construction of your robot is going to be really important on how wide it is and how the wheels kind of splay and how structurally well built it is. And I've seen teams do really well with very, very small wheels, so it's really a matter of how you program them. Take a look at some Lego Technic sets and see the different variations of wheels in Lego.
Allison is asking, I read about a mobile app to use for programming, and she's wondering if you've tried it and if you have any information about that you can share.
Okay, I'm thinking this is the iPad app for Lego Mindstorm DB3. I hope that's the one you're talking about, in which it's a great starter and a good way to really introduce some of the missions, because you only get these blocks on the bottom, so you only get the move blocks, the green blocks, and the orange blocks. So great for a lot of the missions, but if you want to do something more advanced, like creating my blocks, you can't do that. Or doing these state machine type things with my blocks in them and any of the variables, you won't be able to do that in the tablet apps and the mobile apps. So So, but just to make sure, like if it's something different, like there are some remote control apps, those aren't allowed, and only Lego Mindstorm's official softwares are allowed. So up to and including Robo Lab for the RCX, and that's probably the only one that you can get. That's outside of like the Lego stuff. But great for introducing stuff. But if you really want to get into making the program, getting to that advanced level, you'll have to go to the desktop software.
Great. So unfortunately, we weren't able to get to everybody's questions today, but Larry's been waiting a long time, so I just want to make sure that I get his in. He was asking, how do you build in pauses in the big program for attachment change?
Programs. So big program attachment changes are here, actually. You see I have this program change, this press wait for buttons here. To do an attachment change. And if you really need to do it, you can do it within the program as well. So maybe I have mission 1 here, and then I can put another wait for touch, I can maybe use the break buttons. Maybe I'll use the up button instead, so to make sure I don't get confused before I run the next part of the program. So here I know that there's an attachment change if I'm back in base. But really good question. I mean, if you're really good and you can do it with your kids, you can even just wait for time if they're really fast. So instead of having a push button, they can just kind of drop their attachment on and then let their robot go without any real breaks. That's a fun one.
So I do want to take a minute to thank Lee, and thank you to the coaches today, and also any coaches who might be watching this recording when we post it to YouTube. Before we go, I just also want to take a moment to thank our first Lego League global sponsors, and they are 3M and I, Rockwell Automation, and of course Lego. And thanks, Lee, for all your great insights and tips. Good luck and have a great season, everybody.